Hi friends, you are welcome back to Fizadeni, and in today's video lesson, we shall be learning about the topic called empirical and molecular formula. So we shall be learning a two-in-one topic today. So without wasting your time, let's get started. Now, before you can be able to successfully solve questions under empirical and molecular formulas, there are some rules to be noted, okay, that will guide your solving. So let's get down to there. For empirical formula, the basic rules to be followed or the steps to be taken are: the first step is that you must divide each of the elements by their respective atomic masses, because you'll be given some set of elements and you will be what? You are required to divide each of them by their what? Atomic mass, because the masses of each of them will be given either in grams or in percentage. I repeat, it will be given either in grams or in percentage. So you have to first of all divide each of the elements by their respective atomic masses. After you have done that, you will notice that they are not all going to be the same value. So what next should you do? The next step is to divide all true by the smallest value. So comparing the values, the smallest will be used to divide all true, okay, for each of the elements. You will use the smallest to divide all true, okay. Thereafter, once you have done that, the final step is to round up the final answer you get for each element to the nearest whole number. And these are the steps to be followed when asked to find empirical formula. Now sometimes you might be asked, okay, furthermore to find what? The molecular formula of the compound, okay. Now, how do you now get the molecular formula? Okay, there are two formulas to be employed. Now this is the first, okay, this is the first to be used. Now the formula is N equals MO over NEF, where the N here stands for the number of atoms, MO stands for molecular formula, or you call it the what? The molar mass. MO stands for molecular mass, or you say molar mass. And lastly, the NEF, the M subscript EF here stands for the mass of the empirical formula. The mass of the empirical formula. Now, after you have gotten the number of atoms using this formula, you then bring it into the main formula for what? Molecular formula. And this is the formula that you use to get the MF, molecular formula. And what's the formula? MF is equals to EF subscript N. We all know that EF stands for what? The empirical formula. So after you have gotten your EF, the formula of the empirical structure, thereafter you will not use the subscript N, which you get from this formula, so times all true. Thereafter, what you will have will now be the what? Molecular formula for the compound you are asked to solve for. So these are the basic steps to be followed when asked to find either empirical formula or molecular formula. So without wasting much of your time, guys, let's get on to the question on the board. Now looking at this question on the board, example 1, they said an unknown compound. We don't know the molecular formula of the compound, neither do we know the empirical formula of the compound, so it's unknown to us. They said on analysis contained 4 grams of carbon, 0.67 grams of hydrogen, and lastly 5.33 grams of what? Oxygen. Now we're given the respective atomic masses of carbon, hydrogen, and oxygen in the bracket as you have seen here. And then the first question was for us to find what? Calculate the empirical formula. So we are asked to what? Find out what the empirical formula of the unknown compound is. So let's see how we solve that. Solution. Now I'm going to be splitting the board so we can use it to what? Solve the two questions at once. So let's go. Okay? Now we have this. We decide to solve for question 1. How do we get the empirical formula? How do we calculate the empirical formula? Now we'll be sticking basically to the rules I've already given here for empirical formula. So you see how they are being used, okay? So let's get started. The first rule said, divide each element by their what? Atomic masses. So before we do that, what are the elements given? What are the elements that we were told that is found in this unknown compound? We were told that carbon is present. We also told that what? Hydrogen is present. And lastly, we were told that what? Oxygen is what? Present. So we have carbon, hydrogen, and what? Oxygen in this guy that is unknown to us. Now we have identified the elements in it. The next step is to ask ourselves, what are the respective masses for each of the elements? You have 4 grams of carbon, you have 0.67 0.67 gram of hydrogen, and lastly you have what? 5.33 gram for what? Oxygen. Now we know these guys. We will now come back to the first step here, which is to what? Divide each of the elements by their respective atomic masses. So guys, this will be 4 divided by what is the atomic mass of carbon? As given here is what? It's over 12, is it not? Now, what is the atomic mass for hydrogen as given here? It's over what? 1. Atomic mass of oxygen as given here is over what? 16. So we'll be doing this with our what? Calculator. We'll be doing this with our calculator so that we'll be more accurate. Now, 4 divided by 12 is the first question. 4 divided by what? 12. Now, we'll be approximating my answers to, let's say, the second degree. Okay, to make things easier. We have 0.33. Are you seeing that? Then going on to this, let's go. You have 0.67 divided by 1. Any number divided by 1 is what? That same number. That same number. Are you seeing that? And lastly, let's go for oxygen. 5.33 divided by what? 16. 5.33 divided by what? 16. So when we do this division together, we have 0.33. You can also use your calculator to cross-check the answer. Now we have this. This is what we got when we divide each element by their respective atomic masses. These are the answers we got. Now we've gotten this. What is the next step? Divide all through by the smallest value. So comparing these three guys, 0.33, 0.67, and lastly 0.33. Which is the smallest? Is it this or is it this? Because this and this are the same. Now between 0.33 and 0.67, which is smallest? The answer is what? 0.33. So I want you to divide each of them. That's what I meant by divide all through. So let's go. Over 0.33 over 0.33 over what? 0.33. Are you seeing it? This is how it is done. So let's get the answer to each of these. This divided by this will give us 1. This divided by this, let's get it. You have 0.67 divided by 0.33. Now the answer is 2.03. Are you seeing that? And here we have what? 1. Then what was the last step? Round off. We have to round off each of these answers to the nearest whole number. So let's do that together. It will now be approximately what? 1, because 1 will remain 1. Now if you round this up to the nearest whole number, the guy behind the point is 0. It's not up to 5. So I won't add anything to 2. So it will be approximately what? 2. Is it not? Why this will be 1? Is it not? So guys, now you have this. This is now going to be the subscript of the empirical formula of the unknown compound. So how will I now write the what? Empirical formula. I will now say, so therefore, E dot F, okay, for the unknown compound, it's, what is the first element? C. What is its subscript? 1. What is the next element? H. What is its subscript? It's what? 2. And what's the last element? You have 0, that's oxygen. And what is its subscript? The answer you got finally is what? 1. So C1H2O1 is the what? Empirical formula for this unknown compound. And mind you, in a better form, you can say CH2O, because basically in chemistry, the subscript 1 is not usually shown. Okay, so you can just say CH2O. You don't show the 1 and 1. I'm just doing like this for the purpose of basically the molecular formula side we're solving. So you can come here and write, finally, EF is equals to what? C, then what? H2, then what? O. And this is the empirical formula. That is if you remove the 1, 1. Is it not a subscript? Because this is how you have to leave it in chemistry. You don't show the subscript 1. So the final empirical formula is now what? CH2O. Now you have gotten the first question. The next question is now for us to find what? The molecular formula. So this is molecular formula. Molecular formula. We are now going to be finding the what? Molecular formula of this very unknown compound. So I will be using the rule I have already given out on this part of the board. The first rule is that we have to calculate the number of atoms using this very formula. Molecular mass over what? Mass of the empirical formula. So let's go. Let's get the N first. N is equals MO over what? MEF. This is the formula for what? Getting the number of atoms. Now, do we know the molecular mass of the entire compound? Was it given in question 2? Let's check. Calculate the molecular formula if the molecular mass NO is what? 180. So we have this as 180. True or false? True. Do we know the mass of the empirical formula? This is the empirical formula. CH2O is the empirical formula. So we have to find the mass of CH2O before we solve. So we say MEF is equals to, what is this? This is carbon. 12 plus H2, that is 2 times, what is the atomic mass of hydrogen? 1. So you come and write 1, close bracket. What is the oxygen? Oxygen is what? 16, is it not? So if you do this together, you will have 12 added 12 plus 2 times 1 is 2 plus what? 16. So 12 plus 2 is 14. 14 plus this is what? 30. So the MEF of this unknown compound is what? 30. Is it not? Now you have this. We now have the MEF and we know our what? Molecular mass as 180. So let's see if we can actually solve for the number of atoms in this compound. So we can come here and say number of atoms is now equals to, what is our NO? 180. 180 over, what is our MEF? Is now what? 30. 30. And if you do this division, you will have exactly what? 6. So we now know our N to be what? 6. So now can we now get our NF, that is the molecular formula, which is our question 2? The answer is what? Yes. So we come here and say NF, okay, let me just do it on this part of the board. NF is now equals to, NF is equals to empirical formula subscript N. So whatever is our empirical formula, we use the number of atoms to times what true. Our empirical formula is CH2O. Then the subscript will now be what? 6. Good, very good. Now, if you know how to get the molecular formula, it will now be class. Watch this out. There is a 1 here, invisible 1, is it not? So I'm using 6 to times the subscript here, to times the subscript here, and to times the subscript for oxygen. Is it not? For each of them, I'll be timesing them with what? 6, which is outside. So invisible 1 times 6 is what? 6. So this will be C6. Are you seeing that? Now the 2 times the subscript 6 will give us what? H12. Now the invisible 1 here times this same 6, because the bracket is affecting everything. Invisible 1 times 6 will give us what? O6. So the molecular formula for the unknown compound is what? C6H12O6. I hope you understand how this question was solved. Now, if you don't understand, do it to let me know in the comment section. Now, before I give you guys a question, let's take another question. But this time, it will be given not in gram, but as what? Percentage. And let's see how that is solved. So let's get the question now. Alright, here is the second question we are asked to solve. So let's read this together. They said, an oxide of nitrogen. Observe that it said oxide. That is, there is an oxygen in this compound that we are talking about. An oxide of nitrogen contains 30% of nitrogen N. On analysis, they now said, find the empirical formula. An oxide, oxygen is in the compound, nitrogen is also what? In the compound. If they have said a chloride, that is, there's chlorine in the compound, see not? If they have said an iodide, that is, there's iodine in the compound. If they have said a fluoride, that is to say there's fluorine in the compound. But in this case, we're told that an oxide of what? Nitrogen. So observe something. It means that in this compound we have oxygen and also have what? Nitrogen. Is it not? These are the two elements in this very compound. So let's solve this together without wasting time. So let's do the same thing we did for question 1. What are the two elements in this compound? We're told that there is nitrogen and we're told that there is what? Oxygen. Is it not? Because they told us an oxide of nitrogen. If it was a fluoride of nitrogen, it means that there will be nitrogen and there will be what? Fluorine. If it was a chloride of nitrogen, it means that there will be nitrogen and there will be what? Chlorine in the compound. So we are going to to be finding the empirical formula and the molecular formula. And mind you, they gave us the molecular mass. So let's solve for the empirical formula. Rules for solving empirical formula question. The first is to what? Identify the elements in it, which are nitrogen and oxygen. Thereafter, what was the masses or percentage given for each element? We are told that it contained 30% of what? Nitrogen. So I'll come and write 30. You can choose to add percentage, but I'll just write the 30. Now, when we give the percentage of oxygen in this unknown compound, the answer is what? No. Or can we find it? The answer is what? Yes. If there are two elements in the compound, and the first is 30%, what percentage will be left out of 100%? Is it not 70? So this guy will be what? 70% oxygen in this unknown compound. So while 30% is for nitrogen, the remaining 70% is for what? Oxygen. If we were told that it was, let's say, 60% of nitrogen in this compound that is unknown, the rest, which is 40%, because out of 100 you still have 40%, will now be for what? Oxygen. Now we have done this. The next step is to what? Divide each by their respective atomic masses. Okay? We all know that nitrogen is what? Nitrogen is 14, and then oxygen is what? 16. So we'll be dividing each by their what? Atomic masses. So this should be what? Over 14 over 16. So let's quickly get our calculator and see how we can solve this question from this very extent. So the first question will be 30 divided by what? 14. 30 divided by what? 14. Now here we have 2.14. Okay? You can choose to leave yours to 3 decimal place or 2 decimal place. Okay? Let's just make it 3 decimal place. 2.143. We can still do the same thing there by making it 3 decimal place. It's still the same answer we get. Now, for this one, let's go. 70 divided by 16. This gives us 4.375 to 3 decimal place. Now we have this. Now the next step is to divide all through by the smallest value. So between 2 points and 4 points, which one is smaller? Is it not this? 2.143 is the smaller, is it not? So we'll be dividing both by 2.143. So this will be over 2.143 and over what? 2.143. So this will give us 1. Let's see what this will give us. 4.375 divided by what? 2.143. So this gives us 2.04 from our calculator. Now what's the last step under empirical formula? Approximate, is it not? Round off to the nearest whole number. So come here and say, watch this. This will now be approximately equals to what? 1. And this to the nearest whole number will give us what? 2. So what will now be the empirical formula? Empirical formula for this compound will now be, there's nitrogen in this compound. How many nitrogen? 1. There's oxygen in this compound. How many atoms? 2. So the empirical formula, therefore, because I told us that what? We don't give empirical formula as, we don't show the subscript 1 in the empirical formula. So it will now be equals to, let's put it here, it will be equals to NO2, and this is the empirical formula. We have removed the subscript 1 because we don't show it in chemistry. So now this is the answer to question 1. Now let's go to question 2 and see how we can find the what? Molecular formula. So I'll be solving it on this part of the board. And mind you, to solve for the molecular formula MF, we need to know the what? N, the number of atoms. So let's get that fast. N is equals to MO over M subscript E dot F. So what is our molar mass from this question? They said find the what? Molecular formula if the molecular mass is what? 92. So MO is what? 92. Can we get our MEF? The answer is what? Yes. So this guy, now we need to get our MEF. Let's quickly do it as a rough work, okay? We'll do it as a rough work somewhere here. Nitrogen is what? 14. Oxygen is what? 16. Now, 2 oxygen atoms. 2 times 16 is what? 32. 32 added to 14 will give you what? 46. 46. So if you do that yourself, you also get 92 divided by 46. And this gives us exactly 2. So now we have the number of atoms. Let's get our MF, which is what number 2 is about. Our molecular formula. So this is E dot F subscript N. Now what is our empirical formula? Our empirical formula from this question is what? NO2. So we come here and put in bracket NO2. And what is our subscript? Also 2. So now you have this molecular formula now will be equals to, let's see what will be equals to. Now, what is the invisible subscript here? It's not 1. So 1 times the guy outside, which is 2, is it not? 1 times 2 is what? 2. So this will be N2. Now, O2, what is the subscript here? 2. 2 times the 2 outside will now give us what? 4. So this will be what? O4. And this will be the answer for the what? Molecular formula. Molecular formula of this unknown compound. So I hope you clearly understood how I did solve for empirical formula and also how I did solve for what? Molecular formula. So back now, we're dropping one question for you to try your hands on. So let's get the question now. Alright guys, here is the question you are asked to solve. It reads, an unknown hydrocarbon contains 1.52 gram of what? Carbon and 0.13 gram of what? Hydrogen on analysis. You were given the atomic masses of carbon and hydrogen. Carbon is 12, hydrogen is 1. Now the first question is for you to calculate the empirical formula. The next question is for you to what? Calculate the molecular formula if the molecular mass NO is what? 78. Okay? Now the word hydrocarbon shows us that there's what? Carbon in this compound and there's also what? Hydrogen in this compound. So do it to work this question out and feel free to let me know what you think the answer to this question is in the comment section. Thanks for watching. I remain the Academy. See you in my next video.